This is the technical session 3 on WASH innovations in technology and service delivery. Uh, I would like to first of all welcome the today's chair, Mr. Jignesh Mehta. I'll introduce him first and then we'll start the sessions. Mr. Jignesh Mehta is currently an associate professor and program chair of the CEPT University and Master of Urban Planning at CEPT University, and with over 23 years of international professional experience as an urban planner and urban designer in the USA and India. He has led and contributed to several nationally recognized award-winning projects. So today we will have Mr. Jignesh Mehta as a chair. Welcome to you, sir, and I hand it over to you. Thank you.
I'm moderating the session, but I'm not an expert here. There are experts, they are all here. So we will basically spend all of our time hearing from them. Um, and since we have started a little bit late, I think we all will have to try and be on time. So I request all of our speakers to just keep it to 10 minutes, not more. And then after that, if time permits, we will have good round of Q&A. So without any further ado, let me invite Mr. G. Ramkumar. Um, he's going to be talking about some interesting things. He is from RWH Ecoterrain Based Solutions. And his title is Catch the Rain, Distribute Rainwater Harvesting, RWH, Sponge Soil. So, Mr. Ramkumar, please welcome.
I can stand here if you can move the slides. I can stand here, okay? Yeah. I've thought I'll come near to the audience. Yeah. Thanks, sir. Thanks a lot for the lovely words, and thanks to the CPD team. In fact, last time also I was here. Yeah. Mainly, the affection given by the team has been great to me. A great motivator in my efforts. What I'll do before I go into my real presentation, I'll give a crux of what I'm going to talk. The crux. The crux of what I'm going to talk or what I'm trying to practice and propagate is nature's abundant rain, the power of soil, the power of the Mother Earth to retain Earth is enormous. It can retain all the earth, all the water. And soil is a living being. Without water, soil dies. So distributed rainwater harvesting. In fact, we have created the floods and we have created the water problems as human beings by not allowing water to go into the Mother Earth. Can we provide breather holes in the Mother Earth to take the water into the ground by which soil is a living being, the vegetation improves, the climate improves. So all the parameters, what the WASH stands for, is achieved. What I'll run through the presentation and stick to my 10-minute schedule. So this is a crux. What I'm going to show is the live illustrations right from 2000 onwards. In fact, I was with the Indian Oil Corporation, retired as executive director. So Indian Oil has allowed me to do a lot of things. Now I'm practicing it through IIT Madras Alumni Societal Impact Group and also World of Water Forum. May I start? I can press it, no? Yeah, sorry. Okay. Yeah. Let me pray to Mother Nature. One drop of rain harvested gives 1 million in return. One drop of rain harvested gives 1 million in return. Yeah. I've already explained this. Nature gives abundant rain, all these things I've explained. What I want to communicate is our nation receives about 100 to 110 centimeters of rainfall. Our rainfall received is much greater than US or the China or the European countries. Very much. And our cities need, and we are utilizing only 8% of the rainfall. Here a question will be asked, can we make it much higher? Difficult because a rain god has to do a lot of maintain the ecosystem, not to maintain the minuscule human beings who are causing great threat on the Mother Earth. Most of our cities need only less than 50% of the rainfall. Only less than 50%. Yet all the cities, we face water problems. National Water Mission campaign says, catch the rain where it falls, when it falls. I was a panelist speaker in National Water Mission also. Soil holds about 6 to 8 times fresh water of all river basins put together in the planet. It is the largest reservoir of fresh water in the planet. And soil is a living being, nurtures vegetation, life giver for the microorganism. Down we have got a sketch. 50% of the soil, if you take 1 unit of soil, 50% is solid, 25% water, 25% air. That means soil has space, even up to 50%. It varies from type of soil to soil. The soil has space for holding about even 50% water. Now I'll go to the illustrations quickly. This is the Zilla Parishad School at Kupri, Taluka Wada in district Palghar. This was done in the last year. You can have a look. This is the, how is this thing? No, earlier one. No, earlier one. Earlier one. No, not that. That I'll have to point, no? This gives a pointer also? Pointer is not working. Okay, don't worry, I'll explain. Okay. The first sketch shows, it is a school with a old type of building, about 1 acre of land. And here, the problem was, 4 months in a year, the poor students do not get water in the borewell. The solution is we have to give water perennially. So we joined with Inner Wheels Club of Thane Garden City. And with the provision of graded gravel pits, the school has got perennial water. There is a certificate issued by the school. In fact, the icing on the cake is, school student presented this in the district science forum and got the award for the school. The consultant wanted 2 lakhs to 7 lakhs for solving the water problem in 18,000 rupees. So 3 things. Number 1, people joining hands, analyzing the terrain, soil as a medium of water, both for holding and discharge, and very economical design. Oh, but I will not intercept the photograph now. No, sorry. Yeah, it's okay. Yeah. Yeah, okay. Sorry. Yeah. Go behind. Oh, okay. Now is it okay? So even though the project appears very simple, it has got a lot of meaningful studies. Like for example, at a very low cost, nature friendly, we have solved a problem of borewell recharge. The borewell recharge, when many of the consultants take all the water and put it on the bore may die. And the student presenting and getting an award, that means we have propagated this knowledge to the level of a 7th standard student. Shall I go to the next one? I'm okay, na? Yeah. So what is this graded gravel pit? It is nothing. Dig a hole, put some gravel. Gravel means blue metal. Because blue metal percolates water well. The design and these things require some expertise. Yeah. The city ooze, I think all of us are aware, no? Small rain, all cities are flooded. Small rains. Let it be Bangalore, let it be corridor, and thirsty summers. Summer come, we blame. I will ask one question to all of you. Why this city flooding is occurring? Is it because of lack of proper drainage or not? Can you answer me? One question. City flooding is occurring because of what? Is it, everybody says drainage. Drainage is improper. That means my water I should throw it to your house and not deprive water of the soil. Thereby I am sinking and blame the drainage. I am killing the soil and blaming the drainage. Drainage is only a part solution. It should recharge the ground, only the runoff should go. This principle is not being heard. So last presentation also I told them that there should be a leadership change, thought process change. The drain is not supposed to throw water from my house to your house. It should recharge the Mother Earth. Only the runoff should go. Otherwise, we cannot handle this flood problem. And we cannot handle the drought problems. The entire soil is a shallow aquifer. See, you recharge the shallow aquifer, deep aquifers are automatically recharged. People drill holes to recharge the deep aquifer. Shallow aquifer you recharge. The rains we are doing only shallow aquifer recharge. Then the implementation of rain harvesting stormwater drain. That means the drain should not be a conduit to throw my water to your house. It should be rain harvesting drains with micro graded gravel pits in between. This example I'll come. This is the concrete, this is the corporate building of Indian Oil Corporation in Nungambakam High Road near to the Jemi circle. The prime area, concrete area. The question comes, in a concrete area, can you do harvesting? Chirag, can we do harvesting in a in a concrete area? Simple answer is yes. We can see the stormwater drain colored in green. Are you able to see that? We have put graded gravel pits within the drain, 9 inches diameter, filled with stones. The result is no flooding. The tarmac of Indian Oil building is clear, the road is flooded. Diagonally opposite, the Park Hotel was flooded. And the borewell, the buying of the tankers got stopped. This publishes an article. People said that I cannot believe it. I told them, even I cannot believe it. That's the power of the Mother Earth. 3 minutes, good. Here I am covering an example of stopping saline water intrusion. This is the project of Indian Oil in 2000 in a saline area. Here we employed the roof catching and with graded gravel pits. We have improved the water quality from 25,000 ppm TDS to surface water of 600 ppm in summer to 200 ppm in rainy seasons. That entire area, we have put the saline water intrusion, we have stopped it. And not only that, the plant is taking only 15% of the water. We are improving that entire area of 50 acres. Yeah, this is my own complex where I am staying. You are able to see a well, no? The terrace water goes into the well. And 15 years we improved the TDS from about 25,000 to less than 600. And it has become service water quality. It is meeting 50% of the requirements of the house. This is in the Kamagodi Community Park. It's a flooded area. We have, by recharge of 10 million liters into the ground, all the adjacent wells have improved. You can see these very beautiful buildings. Alive projects of senior citizen home, senior citizens living in Thiruvananthapuram. I think this might be the last slide, but not. Here, can you see the beautiful lawn here? You're able to see the lawns here, na? Each villa water goes below this lawn into a gravel pit. So this is an example of 3 types of harvesting. Natural harvesting, harvesting merging with the terrain. This is my summary slide. Harness rain and the power of soil to absorb water, nurturing vegetation for better climate. The beauty of distributed shallow aquifer recharge, practical cost-effective RW solutions, recharging deep aquifers too, to meet our planet's water needs forever. Planet means all our children, whether it is human beings, all our children. The planet Earth will give enough water. Thank you.
Important that all of us understand this and actually put it in practice. We will talk about this a little bit more and we'll take more questions after we hear from the other speakers. Thank you so much. So now I'll invite Dr. Jemi Gandhi, and she's from MG Science Institute. She's a professor and she has been doing some research and she has some amazing talk to give. So we'll listen from you.
Facility to the tap, we have long channels of pipe because of which it is likely to be recontaminated because of leakages in pipe or elevation difference in pipe, or there might be biological recontamination. In our work, we generally focus on total coliform, fecal coliform, and Escherichia coli as indicators or surrogates of bacterial contamination. As per regulatory agencies, there should be zero count of such bacteria in water. And we monitor this through a technique known as membrane filtration technique. To simplify the technique, the illustration is given on the left hand side, bottom side, wherein a set volume of water is filtered through a membrane. That membrane has very tiny pores which does not allow bacteria to pass through, only water is passed through it. So once that bacteria is supplemented on growth media, bacteria grows and we can enumerate it. So using such technique for a period of 12 months, we analyzed the water quality and found that water is consistently recontaminated. We did this study twice in a month, and statistically less than 1% of the times water was not contaminated, that is 99% of the time water was contaminated. We also monitored the physiochemical characteristics and found that residual chlorine was very less, that is below the regulatory agency's level, and that might be the reason for recontamination of water. So there's a practice of using different treatment techniques at the point of use to ensure that water is safe. There are different techniques, and about 1/3 of the techniques utilize UV lamp. There is a diagram which depicts the UV lamp, and interestingly each lamp will have about 150 to 300 milligram of mercury. The challenge with this is, although it's very effective, but mercury is very toxic. It has short-term and long-term health consequences to humans. And WHO also says that light bulbs, as in UV lamps, are one of the ways with which mercury enters the environment. And because of that, we have an international cooperation, that is Minamata Convention, which is signed by 128 countries, which plans to phase out use of mercury in products and processes. The ideal timeline for that was 2020. We are 5-6 years beyond that, and we have still not completely stopped using mercury. Long back, if you could recollect, the thermometers that we used had mercury. Now we are conventionally using digital thermometers. But there is no implementation of lamp source for UV which is not using mercury as of now. So we focused on UVC LED. These are mercury free alternative to UV lamps. The good thing is that they are environmentally friendly, they require low maintenance, they have high lamp life compared to UV mercury. They are also RoHS certified, that is certification which is given on products which does not have any other hazardous material. So we don't want to solve a problem and create another problem, right? The challenge with UV LED is it has very low wall plug efficiency. What we mean by low wall plug efficiency is that it will generate large amount of heat in compared to light. So the wall plug efficiency is about 10 times lower than UV mercury lamp. So if we don't manage the heat effectively, it will short circuit. It will not run continuously for long time period. So we came up with a design which is patented and has already been published, and we can use it for long hours without abrupt heating. So this is the design. The left side picture shows glowing UVC LED device. It is fixed on a heat sink of aluminium. Aluminium absorbs the light, the heat from the back very effectively, and those devices are immersed in water. So further heat management becomes more effective. Now that water proofing is done by a quartz sleeve. So quartz is the only material that allows UV to pass through. If there is plastic or glass, UV cannot be transmitted through it. So there is a UV casing. 4 such devices are immersed in stainless steel photolytic chamber. It is made up of 316 grade, that is quite resistant to corrosion, and it can be directly coupled to the tap source. Here we are using a power box which converts AC light to DC. It can also be connected to photovoltaic panel to effectively utilize the sunlight. And we can see that emission of light is 276, that's a proof that it is in the UV region. Also we can see that the temperature, there is no abrupt change, and irradiance is also stable for continuous use of 300 minutes. We monitored use of UVC LED also continuously for a year, and we found that if water had less contamination, we can operate the UVC LED at a higher flow rate also of 49 LPH, and if at higher contamination, we can operate it at a lower flow rate of 30 LPH. These are the representative pictures. The top shows water which was contaminated and monitored through membrane filtration technique. The dots that you see are nothing but bacterial counts, and it was treated at a flow rate of 30 LPH, which delivered a UV dose of 10 millijoule per centimeter square. And in treated water, we can see that there are no bacterial colonies. I'm not going into the technical details of how this dose was calculated, but there are different protocols that we use to calculate it. Then this photolytic chamber was retrofitted in a system assembly which was commercially procured from manufacturers, so that we can pilot it to show that it was working effectively. So we devised 6 such prototypes, and 6 of them were installed in Goa, 2 were installed in Delhi. And for this we took help from local government. Punch member of that area was, we were extremely lucky, they were very supportive of that. We obviously provided them with our own in-house reports, our publications, patent details, and we also did external lab analysis. We submitted all the documents to them, and they were happy to support us. The right side image shows a method which can be used routinely by common person in the field. It's WHO certified. The bottles, they have certain material inside it which releases H2S gas, and the water turns black if coliform is present. So untreated water detected coliform and the water turned black on incubation, whereas on the left hand side you can see the treated water remains pale yellow in color, which shows that there are no coliforms after treatment. We wanted to challenge this system to a complex matrix also. So far the water that we used was provided by the government. This water we took it from a surface, as in there are 2 lakes, so we took the lake water. You can see on the left hand side the water is very turbid, and we had to do a simple alum treatment to ensure that water is less turbid, and then we could operate it at a higher flow rate. We also wanted to see if we can go it at a higher flow rate, so we devised a different system which could go and operate at 240 liters. The cost and energy economics were calculated, and the smaller system of 30 LPH of 49 LPH could be made with 13,000, and the cost for getting 1000 liter comes to be around 9 rupees. This work was carried out as a part of my PhD at BITS Pilani KK Birla Goa campus, and right now I am working at MG Science. The work was done under Indo-EU Horizon 2020 project Pani Water with Professor Halan Prakash. This is my team, and those who are not from India, I would highly recommend visiting Sabarmati riverfront. Thank you.
This newer technologies that you are trying to bring in is going to be very helpful, hopefully, for much bigger users, much bigger group of users. So please continue this. We will also have more questions for you. Thank you so much. So now I would invite Manish Kulkarni. He is from CWAS. He has been doing some amazing research also at CWAS, and he will talk to us about all the work that he is doing. Thank you.
Thank you, sir. So, as Sir G. Ramkumar sir has already mentioned that he has focused on the recharge, rainwater harvesting and recharge as an option. Going further, I would like to highlight more aspects to it based on our field experience in the Palghar region. So this is a action research project. Action research project. We are carrying it out with the CWAS at the Palghar area of Maharashtra. It is a tribal region and a hilly region. The area is having the rainfall about 700 to 200, 2400 mm annually, and you will surprise that even if it gets so much amount of rainfall, the water does not get stored in the aquifer. So the geohydrology is such that it cannot hold water, and it ultimately lost to the streams, drains and to the sea. So here the rainfall or amount of rainfall that is falling in the area is not a problem. Here actually what is happening underground is the real concern. So going further, we did studied through the literature analysis that due to the basaltic geology, it has a low natural recharge. Around 4 to 10% of the total rainfall that gets fall into the area, it goes to the ground. So, and the aquifer yield also low, about 10 to 100 LPM. And due to the limited aquifer storability, much of the infiltrated rainwater gets rejected as a runoff recharge. So rejected recharge runoff through fractures and alignment. So to overcome these issues, the conventional recharge only rainwater harvesting system will not be the option to make it sustainable over the period of time for a longer run. So, so the solution could be to tap the rainwater and store somewhere or to recharge. Based on the geology where it permits, the storage option plus with recharge can be done. So, to assess the overall condition of the habitations and villages in the rural areas, we have assessed the whole value chain in the habitations, right from the source to the end user. So, here in the rural area, you will see the most of the households are dependent on the dug well groundwater, and those sources are also at the distance. So, households have to walk long distances to fetch daily water. Then the sources are like contaminated due to the droppings and all. So and water quality testing is being done once in a 2 month or once in a 6 month. And at the end, since households have to walk more distances, we should think about something to create some facilities at the habitation level or household level. Going further, we also did assessment in the schools in the Palghar block. Around we covered around 48 schools in the block, and which covering around 1,800 students. So in the schools, about 5 to 6 schools they did not have the storage facilities at all, and they did not have the sources within the premises. So they had to depend on the external sources to fetch the water. To address this issue, we were thinking about what to do. Then we come up with the rainwater storage as an option, since the habitations and the institutions did not have the storage facilities. Rainwater storage facilities could be the options, and it could be the low cost effective. So we tried and tested this solution at the institutional level. So, and one important thing was that despite of the rainfall, the region faces 4 to 6 months of water scarcity. So to tackle these solutions, we tried some recharging structures. So these are the details of. I will not go into the details. So toilet facilities were available, hand washing facilities were available, but they were not in use due to the limited water availability in the habitations and schools. So these are some the schools have or the households have the tin sheets or RCC cement sheets as in roof, and most of the institutions were willing to test these rainwater harvesting structures at their premises. So to develop some strategy, we come up with that to mitigate the drinking water storage. Like I had already mentioned, two-pronged approach can be adopted: storage plus recharge, either recharge or only storage. So in our villages, we have tried this storage option. In order to come up with some solution, we have designed some simple, low cost and cost effective prototype model. We'll see in the next slides. And those storage tanks were built on the above platform. So to give some raised platform, and with the flush system, filter and mounted hand pumps for the fetching the water. Then to align with the Jal Jeevan mission, and to demonstrate the rainwater harvesting system in the communities and institutionals having water scarcity during the lean period. And then formation of the water user group and schools committee can be the solution to operate and maintain the installed facilities. And to continuously monitor the stored water, we have trained the student committee, teacher committee, and the habitations house SCG members to test the water quality within on monthly basis. And before consumption, they can filter the water, they can taste the water, and after that only boiling and all basic preliminary treatment unit, they can utilize those water for the drinking purpose. And to ensure affordability and scalability, a conversion approach is a must. So we have assessed that also. So these are the some of the storage options that are available in the market, and those market options are assessed on the 13 various parameters based on the design flexibility, based on the ease of installation, based on the resistance to the sunlight, and after assessing all the options, we arrived at the one brick masonry storage option with RCC platform above the storage tank. So it costs around rupees 30 to 15 rupees per liter, and it has shape availability. It can be constructed underground. It has design flexibility. It is resistant to the UV and sunlight, and to reduce the risk of the microplastics that can be present if we opt for the LDP and HDP, we opted for the brick masonry rainwater storage option, and we tested this option in 33 locations at the household level. So we have strategized as the 5,000 liter capacity storage tank for the household, and 30 to 35,000 liter capacity for the institutions to meet the drinking water demand plus the sanitation requirement of the institutions. So these are the designs and layout of the rainwater harvesting storage units. And whenever we implement this project, we give training to the students and households regarding usage of water. So the golden standard is the boiling of water. Then you can filter it through the RO or the basic table mounted filters. And after that, you can also give a chlorination dosing around 7 grams per 1000 liter. And after 30 minutes of waiting period, you can consume the water. And to ensure the operation and maintenance of these assets, we have given the operation and maintenance guidelines to each households and to the institutions and the school committees, and they have to monitor these roof conditions, first flush and valve systems, tank inspection, and the surroundings of the area. And main part of this is the treatment, boil or treat water before every usage. So they had to comply with this operation and maintenance checklist, and these are being operated and maintained by the water user groups and school committees. So these are some of few of the pictures that have implemented in the regions. These circular cylindrical shape is the 5,000 liter capacity storage rainwater storage tank, and you can see the platform with steps. These are the 30 to 35,000 liter rainwater storage tanks, and the water inside of it can be fetched through the hand pumps. Those are PVC made hand pumps, and at few locations we have installed the EMS hand pumps. And to scale up, we are providing the exposure visits to the villagers and to the Gram Panchayat officials, to ZP officials. So we are providing 3 liter per capita per day drinking water through such solutions, and these have the impacts on the SDGs. Then to scale up, we have also assessed the new act that has come up, GRAM-J Act. So it also acknowledges the rainwater harvesting as an solution for the drinking water security, but it underemphasizes the rainwater storage option as an option to tackle the drinking water scarcity. So we recommend or to advocate the policy level to include storage option in the rainwater harvesting system, and to include the skilled labor, unskilled labor, and material cost into the act, or the those components into the bill, so that it can be scaled up and it can be made affordable. If you have any question, you can ask further. Thank you. And I would like to thanks the funder of this project, the HDFC Bank Parivartan program, and also the Jilla Parishad Palghar, Panchayat Samiti Palghar, and the CWAS team. Thank you. Thank you.
Manish. Um, Once again, very interesting and very exciting work that you are doing. And it's good to see the scientific comparison of multiple options for rainwater harvesting and what works the best. So we will again have more questions on this. Now, I would invite Ria Triany. Ria, very welcome. And Ria is here from Jakarta. And she's working with the government there. And you are doing some very good work on Eco Act and Green Culinary Initiative. So very welcome here, and we are looking forward to hearing from you. Thank you so much.
Thank you so much. Good afternoon, everyone. Namaste. Thank you for having me here. This is the first time I come to India. So this is a good opportunity from me, because I'm not researchers. I'm from government, from local government. Please introduce. My name is Ria. I'm from Environmental Agency of Jakarta, under Jakarta city government. So I would like to share our project initiative that positions small business culinary not as a pollution source only, but as an entry point of inclusive waste system delivery in dense and urban ecosystem. Okay. Excuse me, ma'am. Yeah. Okay, this is who doesn't know where is the Jakarta. Indonesia in Southeast Asia, and Jakarta is the capital of Indonesia. We have 5 city administrative, like capital in the developing country. Jakarta is very productive, a very massive and dense city, but very productive. Jakarta, we contribute 17% of national GDP, but fun fact is we only have 4% of sewerage coverage. So the other thing, most of households did using septic tank. We still struggling with around 60% of open defecations, but for large business, they have like on-site wastewater treatment plant. Maybe this gap also because informal or small business activity are unseen. So we've been trying right now to change our mind from informality to inclusive WAS system delivery. Sorry. This is the condition of Jakarta. I don't know if you have some issues too. We have flooding. The last flooding is last January. We struggle also with solid waste management, slum area, water pollution, and also for air pollution. So we should supposed to be things in that issue, but the challenge, talking about the challenge of rapidly growing city is not about their size, but how inclusively and sustainably they are governed. Agree? So what happened with culinary business in Jakarta? It's very massive. We have more than 300 activities in Jakarta, but only 9% formally licensed. So they produce many ways from their activities, but as if they're unseen, they exclude our formal WOS system, not only our formal WOS system, but exclude our routine inspections, and also our law enforcement and subsidiary. So what happened with environment pollution control strategy in our city? Before we only focus with supervision and law enforcement, but we forgot one thing. We forgot to educate people, we forgot to engage people and other stakeholders. Now we try to change everything, and we designed this program in earlier 2025. We called it EcoEg. It's kind of environmental development program based on the principle of collaboration between various parties and action that is solution-oriented, implementable, and sustainable toward Jakarta as global city. So E from education, X from action, co for collaboration. So we try to engage all the partners that we can work together. And for priority in 2025, we highlight the medium, small, micro enterprise because they're very inclusive in our policy and regulations. This is the milestone of our project. We begin with a lot of meeting, coordinations, training, workshop, forum group discussion, either internal or external. First, we disseminate the regulations, policy about the environment. Then we give them knowledge about how to manage the environment. Then we determine together where is the location to be pilot project and what kind of business scale that we can focus in that year. And we also determined what kind of mechanism that we can do to as environment guidance program. Then also we have like shared commitment together for environmental management. Then after we we conclude that for the pilot project we focus to culinary business in Jakarta. So we try to collect the data. We engage any technical agencies in Jakarta. Also, we collaborate with urban level, district and sub-district level to collect the data and to validate the data. Then for planning, we do educations like technical training to in 5 administrative theories. The target is small business culinary actors. Wow, 3-minute left. Okay, we skip this. Then the pilot project that we launched on October, we call it Green Culinary Program. We choose Cawang Sub-District as our pilot project with some reasons. And this is the implementation phase. Right now, we are in implementation phase. Even is the early stage, we calculated from 231 culinary business that joined this program. They have around 40 meter cubic per day of wastewater, and they have 61 liter used oil and 18 liter food waste. So on next February, on second week of February, we will establish the green culinary community. This is the goals and objective they have. Oh, I think this is not the latest presentations. Okay, I have the latest presentation in the committee. Okay, next, this is kind of solution that we design. We define to medium scale, small scale, and micro scale based on their capital and their income. So this is the solution. The micro scale is the top priority because it's very inclusive. It's more like we provide them technology, appropriate technology for this, but we collaborated with many partners from academic researchers or from big industries that focus on culinary and also many other CSR partners. We also touch their extended production responsibility to collaborate in this project. So it's not only about the intervention of technology, but also how to increase the economic and social with promotion and branding, how to increase the innovation product, and how to give exhibition stand support, and how to do training support. Oh, okay, this is a business model that we design. I'm sorry, I have a better presentations, but it's not the latest. But yeah, sorry, it's in Indonesia, but we try to define from key partners until the revenue and cost structure. Oh, sorry. Oh, it's not complete. Okay, this is the challenge that we have. Of course, level of understanding among business actors will be different. Time available to business actors because they not only own, but they work for their business. Also, street vendors, operation move around. I don't know if you have here street food because they don't stay in one location, they move around. And for wastewater treatment service are still limited to government-owned enterprise, limited road access and business location, coordination and egocentrically among related institutions. I think it's time's up. Okay, thank you very much. I'm sorry for the presentation. You can get the complete presentations. Yeah, thank you.
Um, so, Ria, thank you so much for this presentation. Don't worry about the slideshow because we all understood what you are trying to say. And I think it's very, very good, very fantastic. We'll have more discussion hopefully on that. Now, last but not the least, I'd invite Meghna Malhotra. She is director at UMC, and she has been doing some great work since long time. So, we would love to hear from her.
Thanks. And at the outset, I would like to say that I do not like this work to be bucketed as an innovation. This is something that rests on intent. It rests on simple management improvements that have to be done. It's non-negotiable. So it's not an innovation of sorts. I'm going to talk about people behind our sanitation improvement and the whole sanitation success story that India has built on, right? The Swachh Bharat and Amrut and a lot of other things. But what about the people behind it and what really needs to happen? And I'm just going to present a few learnings based on our work. And again, it doesn't have to be bucketed as innovation. It has to be just done. A quick recap. I represent an organization called Urban Management Center. It's a not-for-profit organization, and we've been documenting fatalities in the sanitation sector for a long time. And again, this is based on whatever the media reports come out with. very, very shocking numbers. And when we were getting into the detail of it, and this is again what is reported, a lot of fatalities don't even get reported of workers, because a lot of these fatalities also get reported as construction workers' deaths. This was a new septic tank that was constructed, and we don't know why somebody just went inside and fell unconscious. So a lot of it, but when we started decoding this data, we realized that when we began this work about 8-9 years back, our understanding and our feeling was that a lot of these fatalities were happening in sewered networks, right? Because that's the thing that we have in our minds, but 60 to 65% of these fatalities are happening in septic tanks and desludging. And most of these septic tank work happens very informally, because our local governments do not see it as their responsibility of doing desludging work. Sewer network, the cities that are sewered see this as their responsibility, right? It's part of their work, but desludging is not. And so hence it's an intent level issue. And a lot of these fatalities also, it's not that one worker dies. Whenever a fatality has happened, there are multiple people who have died. So in the same instance, one person went in, didn't come back. The second person went inside to check, didn't come back. So on an average, roughly 2.5, 2.6 people die in every such incident. And it's also linked to a lot of other challenges that our cities are facing. And if you look at, this is some work we've been doing along with the government. We started this work in Odisha, expanded to Tamil Nadu, and it's happening nationally now. And all of this is happening, again, basically visibilizing workers. Who are these workers who are actually doing this work? In India, especially because it's a particular section and a subsection of a society that is relegated to doing this work. And hence, who are these people? So we really spent a lot of time, worked with the governments on enumerating these people, because it is this section of the society that is completely devoid of any entitlements. So even if you're talking about urban poverty alleviation programs, these people who are actually the subcaste that is doing this sanitation work is at the fag end of the spectrum as well. So a lot of enumeration work has happened. And I think the reasons for this fatality, and fatality at least comes out in the newspapers. Morbidity doesn't even come out, right? The kind of health challenges these people have and this community faces because of lack of mechanized work that's happening. And so our entire push over the past few years further to enumeration has been that we have to do this in a mechanized way. Only machines can do sanitation operations and maintenance. And when I say sanitation, it's mostly sewers and septic tanks. And if you look at across the value chain disconnect, and I think it's also, there's a lot of intersectionality between the way our building bylaws work. We have mandates for what kind of septic tanks should be there, what size should be there, but it's not followed on field. So when it comes to building plan permission processes, when the site inspection process, are our septic tanks checked? Where are they? Are they at the back end? Are they at where you were shown it in the, when you were actually doing the plan permission process? And so that's where it begins to fail, right? So this is a big failure. Also, a lot of these septic tanks and a lot of our households and a lot of the way our Indian cities are, you have extremely narrow lanes. And you have very, very organically grown settlements. And how do you actually reach out to that septic tank or that pit, which is really, which is very difficult to even reach? Also, because our septic tanks are not built to standard, what is happening is that you're desludging this once every 10 years or so. And because you're desludging this every 10 years, the sludge is so hardened that it's very difficult to even, remove it. And so and that's where when you talk to a household or when you talk to that property owner, they say ki nahi, aadmi to utarna hi padega, person will have to go in, because otherwise the sludge will not, somebody actually needs to go and cut the sludge inside, right? So you have scheduled desludging processes, you have all of that written in our bylaws and our mandates, but it's not being followed. And CEPT and CWAS has done some fantastic work with scheduled desludging in Vice and NER, and these are models that really need to be talked about much more. Also, so I think across the value chain, and we've done this study, so we started looking at when machines fail. So either you don't have machines, or you have machines that are not able to do the work that they are able to do, that they are supposed to do. And so we did this exhaustive study in a few cities in Odisha, and we also did this study across other few states to understand where machines actually fail. And all of this work really helped us to also, and when we were talking to urban local bodies and city managers of what kind of challenges they have. So we got together on one platform, city managers, the decision makers who have the money, the budgets, and we got manufacturers of equipment together. And we actually got them to talk to each other that, what's the problem? Why not? And there were a lot of issues when it came to what was happening. So again, a lot of machine failure, a lot of cities said, and it was also the way they were contracting out or the way they were procuring these machines. Smaller cities especially, they were procuring these machines without a long-term O&M kind of a horizon. So when you don't have those kind of O&M horizons, what was happening is that the cities did not have capacity to continue maintaining, or even small things like spare parts being made available. So what happens? So these are very small things, not rocket science, like I said at the outset, but these need to be put in place. Also, when we spoke to operators of sewer line cleaning or for septic tanks, what they said that there is a mechanism in the government systems that if at all there is a possibility that a machine is not able to clean a septic tank or solve for a clogged sewer, you may need confined space entry. Somebody with all the kinds of PPEs, safety equipments needs to go in. But there are protocols, there are permission processes around it. Those permission processes itself are not there. And if the permission, you need to go to the collector to get permission, you're not going to get it in a few hours. And that's when you have to solve a problem, then you have a man or you have a person going in. And that's what has been happening. To solve for all of this, and this is just a slide that is kind of trying to put together all of the governance and technical challenges around it, we said, what is the fix? Do we have even finances? If all cities had to procure machines tomorrow, do we have the wherewithal to procure machines that you need? And also, again, talking about life cycle costs, right? It's not, our city governments are fantastic at procuring, but what about maintenance? So can we look at life cycle costs, and can we look at systems that you need to put in place for ensuring that these maintenance systems are put in place? And there are a lot of these existing kind of instruments that are there. Swachhata Udyami Yojana is there. There are formal credit mechanisms that are there for cities to kind of use and buy machines, but these are not, again, boils down on cities' capacity and how they're doing it. When we spoke to city governments, a lot of questions. And so to kind of put this all together, what we've created is a Swachh Mech tool. It's a city level needs assessment, and I'm going to stop at this. This is a rapid assessment that you can do at a city level. Assess what your problems are. There will be, and again, you'll have to do a granular assessment. There might be parts of a city where certain machines may work. There are some parts of a city where certain machines will work. A lot of our cities are also mixed. You have sewered and you have septic tanks all together. And how do you do this together? And so this is a Swachh Mech tool that we are now supporting the Ministry of Social Justice to work with and help cities actually even put their heads together on how do you not only procure, but then look at maintaining this in a long term. So I'll stop at that. Thank you.
Thank you very much, Meghna. I think this is a very, very important issue that all of our cities are facing, and it's not just an issue, but it's also a question of life and death. So, very important point, and I think it's amazing work that you have done. Now, what I would request is all the speakers, if we can just bring our chairs here and we can sit here, and then maybe we can have more of a round table kind of discussion as well. So all of you, I'd request all of you to participate in the questions, or if you have any ideas, thoughts, let's hear from you. And as I said, I'm not an expert, so this first time also I'm kind of thinking about these things. So thank you for sharing all these things. Now let me just open it for the questions from the audience, and we will probably have 10 minutes of Q&A discussion, and then we can close it. Anyone from audience, any thoughts, any ideas, any questions? I believe a lot of you have been thinking about this, right? Yes.
So first of all, very wonderful presentations from all of you. My question was about this topic only. So currently, I am pursuing Masters in Urban Infrastructure, and my DRP topic kind of revolve around this WASH innovations and identifying certain challenges between water and sanitation sector, and then finding emerging technologies to solve them. So whenever we see the value chain of water and sanitation, there are many loopholes. Like for example, we like Meghna ma'am said, or most of the presenters said, ki there are certain aging infrastructure or problems, technical, operational, and environmental challenges which we are facing. So my ultimate question was like there are various Indian cities which are resolving them. Like for example, many such challenges are being seen in Delhi, Kolkata, or something like in north or south states, and most of them are using like SCADA or certain technical challenges, but still the problem or the issue which we see is not getting solved. I don't know how to mention it, but it's not getting solved properly or something like. And talking about the solid waste management sector altogether, so I studied like in semester 2, so we studied a whole lot of SWM. And so my question is to you personally. Sorry, I forgot your name. So yeah, so the thing
Yeah.
is, my question is to you that if we look at the SWM value chain, most of the value chain is formalized, and there is mainly loopholes in it where the informal sectors play a major role, like for example rag pickers or something like that. So that tapping or that certain percentage is not covered in the value chain, and the overall then the perception of we saying the net we should involve the net zero type of a thing, like a goal where the waste is not gone to the landfill, and the whole concept of then circularity and this. So what is your thought or in that key? For example, this informal workers which are managing a whole large sector of solid waste. So should be they involved in the formal value chain, and if they are getting involved, then what all, obviously there are certain challenges, then I want to just know about it.
So I think, if I understand correctly, the question is more about how. Oh, that's fine. You can keep it there. About how the various parts of various actors working in the city, picking up the garbage and the solid waste, how are they integrated in the system? I don't know if that is something that you have studied in your city, But I think it'll be also good if you can share your perspective on that. I think that was the question.
Okay, so it's about solid waste management. Yeah, is it correct? Yes. Okay. The existing happen in Jakarta right now. So we only have waste management, but we forgot about waste preventions. So we are struggling to send this, most of the solid waste to the landfilling. And we only have recycling, but recycling is only not less than 15% of our solid waste. We produce 8,000 ton per day of the solid waste. Now we have a RDF facility, but it's still calculated about the efficiency to reduce the waste. But that's the first time, at the first. And the second one, we forgot about the inclusive business, small business. For example, the culinary business is also like they depend on the government for their waste. But in this project, we try not only to educate them, but try to change their behavior and how to introduce them about the waste prevention program, like the reduce and reuse, and how to link them with the economic benefit and social benefit. That's what we will do in this year. Yeah. Is it answer your questions? Thank you.
Thank you so much. Any other questions?
So, people in societies who have some of their land, say, not tiled, so then there will be some water logging there, and of course it doesn't seep in instantly. So they'll be like, we'll tile it. So that is the general mindset which is seen almost everywhere. So, and you mentioned having multiple points where water could seep in. So, what are the challenges when it comes to changing people mindset? And how do you envisage to cater to it?
Madam, your good name? Pardon?
Tanvi.
Selvi.
Tanvi.
Talvi, okay. Madam Talvi, you have hit the nail on the head. The people, many of us are not aware of the ability of the soil to hold water. That's why it's called sponge soil. Anything which can absorb can be sponge, can be an aquifer. So when we do not allow the water to go inside, in fact, if none of the buildings were there, my time is up.
All of us.
Ah, okay, okay. So I will answer that. I thought you declared my time is over, not yet. So I was just joking. In the case of soil, many people do not understand, many of us, that I'm not talking about ordinary people, the policy makers, that soil can absorb water. The top layers of soil become slightly clay or plastic because of walking and other things. So what happened? We provide a small breather hole. Even in the concrete area, we can use the drains, stormwater drains, to put up micropits and take the water inside. In fact, my entire effort in all these projects, what I've shown you, maximum time has been spent in convincing the people that this will work. Even if we're doing it, people say it doesn't work, then I have to tell them that these are the results. The monitoring systems, using people who are interested. I do not know whether I answered your question. The main challenge and the only challenge is convincing the people, especially the educated. That has been the challenge. Once we solve this problem, we will be a water surplus planet. Okay. Then one more point I want to answer, adding on to Mr. Manish. Have I answered it okay? Yes. Yeah. Sir, asking to Manish, I think whatever he is doing and what I am doing is in sync. He has shown certain examples of water collection using artificial structures. That is costly one, so it is employed with a lot of care. Like I showed the Ennur, which is totally with saline water, where we caught on a huge tank of 3,000 KL. We have reaped the money back. In your case, in his case, I have suggested one small solution. That means gravel pits combined with open wells to draw the water. One technical parameter what I would like you to study is the velocity of water in the soil is very low. Once you start putting and taking the water out, you are using the top sponge. So you will have better results because your rainfall is quite high, 1,700 mm to 2,400 mm. This will work wonders. That is what is being done in Kopri, which is in Palkar district, but in a different area. The bore is having good, excellent water, and this is a dilapidated old school. And so I think I have added to what he does. We are in sync, and we will be in touch. It will be a great pleasure for me to add value. Thank you.
Thank you. Thank you. So, I think we have probably, we are running out of the time. What I suggest is all of you to please contact our speakers after the session, and I think you can have much more lively discussion. But thank you all for this amazing presentations, and there's a lot that I have learned. I'm pretty sure all of us have learned. So, to be continued the discussion. Thank you.